Okay, we're talking about Coulomb's law and the general way of writing Coulomb's law. Okay, we're talking about Coulomb's law. First, you review the properties of electric charges in your lecture notes, but we know the form for writing Coulomb's law. In a general way, looks like this. Oops, I forgot the K, Q1. That's the electrostatic constant, Q2 over R12 squared. That's the distance between the charges. That's the name of the 2-point charges. This is a vector equation, so we put a vector sign, but the direction depends on the situation, so we write it this way, indicating it's just a numerical absolute value, and so it doesn't depend on the sign of the charge. The direction has to be determined from the situation. The format looks like this. What this means is the magnitude of the force between 2-point charges Q1 and Q2. If we actually draw 2-point charges, and I'll make them big enough, they're not really points, I'll make them big enough so we can label them, and we make the 2 charges positive, and they may or may not be equal. In this case, let's assume they're equal. We call the first charge Q1, the second charge Q2. We let these both be equal to some quantity that we won't mention. It could be 15 microcoulombs, but we're going to leave it general. We're just going to call it capital Q. So this indicates that they're both positive. They're both the same quantity of charge. And so we know from our properties of electric charge that they're going to repel each other. So we can show that by 2 vectors. The vectors are equal in length because they're going to repel each other equally. That's Newton's third law. The repulsion of 1 on 2 is equal and opposite to the repulsion of 2 on 1. And so this force on the first charge, we would label this as the force. We'll do it as a magnitude. Oh, I need to erase that line. The force of 2 on 1. That's the convention. So the magnitude of the force of 2 on 1 is going to be K, the magnitude of Q1, times the magnitude of Q2, times the distance between them, R12 squared. It's a so-called inverse square law. As the distance doubles, the force will become 4 times weaker. That's an important characteristic of Coulomb's law. So in this case, if we didn't label the distance, but let's call this distance the distance between R1 and R2. And for this problem, we could give it a number. We could just call it D. I mean, we could call it 15 centimeters, but we're going to not give it a number. We're just going to call it D. In this case, the magnitude of the force of 2 on 1, using the symbols rather than the numbers, would be K. Since both charges are the same, Q1 times Q2, the magnitude is Q. That's going to be Q squared. And that's going to be divided by the distance between them squared. In this case, the distance is D squared. So you want to get used to not necessarily having numbers. In other words, Q1 could be plus 15 microcoulombs, and Q2 would also be plus 15 microcoulombs. Since we're not giving a number, we're just calling it Q. The expression looks like what you see here. Okay, we're going to move on to slide 2.